Hello and welcome to this course on Docker and Kubernetes. Let me briefly tell you about this course and the prerequisite to learn this course. The course name is Docker and Kubernetes, and we can blindly tell that Docker and Kubernetes are the heart of the entire DevOps. You may be using many tools in DevOps, but without Docker and Kubernetes, you cannot have the DevOps culture. So this Docker and Kubernetes are for containerizing the application. And from basic to advanced level, we will learn what is container, how to create a container, how to deploy the containers into Kubernetes cluster, which is a distributed environment with multiple Docker host machines. The statement that I have made may not be understood at this, but slowly you will understand these things. So the course name is Docker and Kubernetes. The duration is 45 days. Okay, so that means it will span across about 2 months, constituting about 45 classes. Okay, friends, can you see my screen? Somebody has said Naveen is unable to see my screen. Others can see my screen, right? Yeah, okay, that's fine. So the course duration is 45 days and each class will be 1 hour. Okay, so that is from 8 p.m. to 9 p.m. Indian Standard Time, IST. Then fee is 4,000 INR. Okay, and classes will be from Monday to Saturday. And most of the students are not happy with this long duration for the Docker and Kubernetes. Let me tell you, some people asked me that the entire DevOps course is being taught in a span of 2 months. Why you are taking 45 days to Docker and Kubernetes? Okay, because we will intensively and extensively cover the Docker and Kubernetes so that you will be industry ready in these two tools. Okay, so this is the reason the course duration is somewhat lengthier. So generally you will find the courses of Docker and Kubernetes just 15 to 20 days, or at least in 2 weeks it will be over. Okay, but this is not the case with my course. This is one thing. And I think this is the brief about the course. I don't want to take much time in explaining this again. And you can contact the institute people to pay the fees. Okay, so this is the thing. Without wasting much time, let's well into the discussion. And what you will get in this, you will get live classes plus recordings plus my entire notes will be shared with you. Live classes through Zoom, you know that recordings will be provided through Google Drive, and material, how the material will look like. For Docker, about 70 pages. Of course, sometimes we will be navigating to official documentation as well. So at least it is about 70 pages, and mostly it will be about 100 pages if you go to the other documents wherever necessary. Okay. And this is for Docker. Coming to Kubernetes. So this is also, it is approximately 100 pages, and you can use this entire material in our real time. And apart from this 100 pages of notes, we will be going to official Kubernetes documentation wherever necessary. Okay, so what you will get? You will get live classes, recordings, along with my entire notes will be given to you. This is the brief about the course. And so the course content, anyway, you know what's the course content of Docker and Kubernetes. Everything will be provided. You can go to their website and you can see that. Okay. So Plato, in his philosophy, has said that, who said it? Plato said that necessity is the mother of invention. Necessity is the mother of invention. Necessity means need. So he says that necessity is the mother of invention. It means whatever the mankind has invented, right from the agriculture to the science and technology to the nuclear weapons, all these things were invented because of their need in that particular time. For sorry guys, for example, the agriculture was invented because there is increasing need for food for growing population. To meet the food requirements of the growing population, man has invented agriculture. Various diagnostic tools, various operations and surgeries were invented because there was a need. There is a problem. We have to fix that problem. To fix that problem, we have to invent something. So that is the reason the need or the necessity is the mother of invention. Why I'm telling this now? Because the concept of containers was invented by the software industry because some problem was faced by the industry as a whole. What was the problem? Why there is a need for inventing this beautiful technology called container? Okay, so now let me explain that problem. Because some tool was invented means there is a problem for that. There is a problem in that time. So to rectify the problem, the tool was invented. Now, in traditional software industry, okay, how the applications were deployed. In traditional software industry, how the applications were deployed. So you know already that every software development lifecycle, SDLC, every software development lifecycle starts with development of source code. Every software development lifecycle starts with development of application or the source code. So that means a team of people called developers will be writing the source code for the application. Okay, Bala is asking, how do we contact institution for paying fee? And in few minutes, they will be posting some messages in the chat, Bala. So I will give their contact number as well. Okay. So every software development life cycle starts with the development of source code. This is the first step. Of course, the analysis, the budget, everything will be there, but the actual implementation of a product will start from the development of the source code. When we say source code, it is nothing but combination of multiple files. If you take Java file, the Java application, there are many Java files will be there, and of course they will be packaged into an artifact. That artifact we will consume in Docker and Kubernetes for high available deployment. Okay, so the first stage is to develop the application source code. Okay, so it is nothing but what? It is a code. Okay, this is the code. So who develops this? The development team will do this. After that, let's suppose that this is a development environment. When they are developing, so they will be installing the JDK of a particular version to develop the Java application. So initially, they will test the application in the development environment. So in dev environment, it will be tested. Then after that, what has to be done? So this is a machine. Let's suppose that this is a single machine, a single developer is there, and he has developed this source code. Okay. In this situation, the developer may be having the Windows machine. Okay. But the developer requires Linux machine to develop that particular application. I repeat, developer is having Windows operating system with him, but the application cannot be developed or cannot be run in the Windows environment. What we have to do? We have to give him the Linux environment. Okay, so what are the different cases by which we can provide the developer with the Linux environment? The thing is, we can give him the new laptop by installing Linux in it, but that is the waste of resources. He has the Windows operating system in his in one of the machine which company has given. To provide him with the Linux machine, buying a new hardware is a method in the olden days. But after invention of hypervisation, okay, and the tools that are used for the hypervisation is hypervisor. Okay, so hypervisor I am unable to get rid of this particular panel which is there here. So it is causing issue. So our requirement is that this is the machine which is given to the developer. And this machine will be having some specifications. What are the specifications? Let's suppose that memory of 32 GB. Okay, let's suppose that CPU, 8-core CPU. So this is the hardware of the machine which is given to the developer. And in this, what is installed is Windows operating system. In this, Windows operating system is installed. But later, the developer found that Windows is not compatible for the application that is trying to develop. In that case, what we have to do, we have to provide him with the Ubuntu machine. So in the olden days, what happened was the company has to purchase a new laptop and install Ubuntu in that and give that to the developer. Do you think this is a cost saving mechanism? No, we are buying two machines for the same developer. It's a waste of resources. So the concept of hypervisation was introduced. So the hypervisation, what it does is, the hypervisor that should be installed, the hypervisor enables us to create or to install a guest operating system on top of this host machine, host operating system. That means within the same machine, within the same hardware, let me compress it a little bit. Of course, it's not needed, but it's looking ugly. Okay, that's fine. So the concept of hypervisor, the tool hypervisor will enable us to install guest operating system in the same host machine. Okay, so here in this operating system is called as guest operating system, and this is Ubuntu. Provided that the sufficient resources are available in the host machine. So the resources, I mean to say the memory and CPU. No doubt that to install Windows operating system, some amount of memory and CPU will be consumed. And to install hypervisor, some amount of memory and CPU will be consumed. So of course, that is consumed. We have eliminated the need for purchasing new hardware from the vendor. The developer needed the Ubuntu operating system, which we have installed in the same host machine with the help of hypervisor. Okay, so this is the advancement. But why the concept of containers was introduced when we have the hypervisor technology? Okay, so I will tell you that. So now, from this machine, let's suppose that this is a machine. This is a Linux machine itself. Let's suppose that here the developer has developed the source code. 1 minute, friends. So in this machine, the application was developed. That's fine. So we don't want that. So we came here. So in this, the application will be developed now. Application development means writing up the source code for the application. Software terminology, So that is the case. So what I want to do is I want to just bring this to a bit lower. Okay. So here the application is being developed by the developer. For this application to develop, for example, if it is a Java application, in this, what needs to be installed? The Java has to be installed in this. Java and other necessary binaries have to be installed in the machine where the application is being developed. Okay, so now let's forget about this. So here, once the application is developed, that means once the source code is written, what is the next step? The source code has to be pushed to some central repository. The source code has to be stored or saved in version control system like GitHub. Okay, so let's suppose that this is GitHub. So now the application A, that means the source code of the application A is stored in the central repository. Now, so when the application was developed, the developer ensures that the application is successfully running in the dev environment. Okay, so then only it confirms it and it will push that to the central repository like a GitHub, Azure repos, or Bitbucket. Okay, so like that, number of repositories were there, and GitHub is the most popular one. So now the application source code is available in the GitHub. What needs to be done? The application has to be thoroughly tested. The application has to be thoroughly tested. For that, the application has to be deployed into the QA environment or the testing environment. Okay, so now let's draw the testing environment. Let's suppose that this is the testing environment. Then this application has to be deployed in this. Remember that for these applications to be successfully running, what needs to be installed? The Java and other related packages which are required for this application A has to be installed in the QA machine as well. Okay, so in general, what I'm telling is dependencies. Okay, so Java and other packages and libraries together, I'm calling them as dependencies. These are the dependencies required for the application A to be successfully running. So here also, let me name it as dependencies. Okay, so the necessary dependencies have to be installed in the QA environment as well. First thing is, here also the Linux environment should be there, because that's what we thought, that we assumed that the application can be developed in the only Ubuntu environment. Okay, so if the application wants to be tested, here the operating system should also be seeing that of the dev environment. So here it is Ubuntu, here also it is Ubuntu. And we have installed the dependencies which we have installed in the dev environment. And please do remember that this application A was successfully running in the dev environment. Now, once this application A is deployed in the QA environment, the application failed here. The application failed to run here. The application failed to run here. What are the possibilities for the application to be failed? The same source code which we have stored in the GitHub is deployed in the QA environment, but the application is failed in the QA environment. Why? There are different reasons for this. Here, the operating system should be same. Okay, so somehow we manage that. Here also, the Ubuntu operating system is installed. But why the application fail? The operating system, the Ubuntu operating system, which we have installed in the dev, may be Ubuntu 18. It is Ubuntu 18 version. But here it may be 20. Here it is Ubuntu 18. Here it is 20. That may be the reason for the application failure in the testing environment. Let's suppose that we found that the operating systems are different in the dev and QA. So that's why the application failed to run in the QA. Then what we have done is, here Ubuntu 18 is installed. What we are doing is, we thought that because of the operating system version difference, the application failed in the QA. So what we are doing is, we are installing 18 here as well. So now there is no doubt that the operating system which is installed in the dev environment is same operating system that we have installed in the QA environment as well. But even after making this change, still our application is failing here. The application was successfully running in the dev environment. We doubted that the application failed in the QA environment because of the fact that the operating system version in the QA environment is different from that of the dev environment. So that's why what we have done is, we have installed the same operating system version in the QA environment as well. But the problem is still persisting. The application still failed in this QA environment. What can be the reason? Here the reason can be the dependencies. We may be missing some dependencies which are required for this application A. For example, let's suppose that there are about 8 dependencies that are required for this particular application A. But here one or the other dependency may be missing. Yes, there is always a possibility for the dependency to be missing. So that may be the reason. And somehow we managed that the same dependencies are also installed in this. If that is the case, still even we have installed all the dependencies, still our application is failing in this. Why? We may be installing all the dependencies which are there in the dev environment, but the dependencies versions may be different. For example, the Java which we have installed in the dev environment, that may be Java 8. Here coming to the QA, it may be Java 11. So all these problems were existing because of the changes in the environment. The application is failed. due to operating system version conflict or missing of some dependencies or different versions of the dependencies. All these things are causing the failure of the application in other environments. So the firefight is happening. What is called as firefight. Firefight between dev and QA team is happening. So that means dev people will tell that the application is successfully running in the dev environment. But coming to QA people will complain that the application is not running in the QA. 1 minute, friends. I'm getting a call from Mr. Yeah. Okay, friends, let's continue. So the QA people will show that the application is failing here, but dev people will tell that the application is successfully running in that. So there is a fight happening between development team and testing team. Okay. So why this conflict came? Because of the environment difference. The environment which is there in the dev is not maintained in other environments. If the application is not tested in the QA, how it can be deployed into the staging or UAT or in production? It won't be moved because that is not tested thoroughly in the QA environment. Okay. So that's the reason that was the problem existing. Okay. So now imagine a situation where we can transfer the application along with its dependencies. Imagine the situation where we are able to transfer or ship the application along with its dependencies. Okay, so now what will be there here? Imagine a situation where we are able to package the application along with its dependencies and store that package into some central server. Okay, and the same thing can be deployed in the whatever the environment that you want. Imagine this. Imagine the situation where there is a possibility for us to package the application source code along with its dependencies and ship it to some central server, and from there we can deploy that into the QA environment or other environment. So the problem that we have eliminated here is now the same application and the same 8 dependencies which are required for this application are same thing we have packed and same thing we are deploying into the QA environment in a box. So maximum problem is rectified here. Of course, this operating system, we will understand how to eliminate that as well. So here, the application along with its dependencies in the traditional method, only the application source code was stored into some central repository, and the dependencies and other things we are installing. Okay, so there is a possibility of missing the dependencies, or some version changes will happen that will cause the application failure. But in this situation, what we are doing is we are packing the application along with its dependencies, which are there in the dev environment where the application was successfully running, and that package we are storing into some central repository, and from there we are deploying into the whatever the environment we want. So here we eliminated the environment differences because the same environment is being carried from the development environment to the some central to the QA environment. If this is thoroughly tested, it can be deployed into the UAT environment or the staging environment. The same box can be deployed. This is called as containerization of the application. This is called as what? Containerization of the application. Containerization means the process of creating or making containers is called as containerization. Then what is container? Containers are everywhere, friends. Containers are everywhere. If I search for containers, see, if we have the knowledge of shipping industry, the goods are transported using containers over the seas and oceans. So what are containers? Containers are nothing but empty boxes. Nowadays, in road transportation also, the materials or the goods are being transported using the containers only. Containers are nothing but what? Empty boxes. Containers are empty boxes where some material is put inside of them. Okay, so of course these are also called as containers. Container means something that will contain some material. Okay, so this is the example of containers. Okay, so these containers will be loaded into the ships and ship will carry them. Okay, so of course I will tell that example as well. So that is the container. So in container, what we do is we will put the application along with its dependency. With that, the problem is eliminated. Okay, so we will see practically. Then, how this container technology will work, I will tell you that now. Okay. Now, let's go to the shipping industry. This is very basic thing and which should be thoroughly understood to understand the concept of containers and the Kubernetes. Okay, so let's suppose that there is a ship owner who is owning a ship of capacity 100 tons. Let's suppose that this ship can carry the 100 tons of material. Okay, so the owner will be having this ship. Let's suppose that there is a merchant or there is some person who wants to transport about 30 tons of fish and 10 tons of some raw material. Okay, so there is a person called A. A wants to transport this material. What it is? the 30 tons of fish and 10 tons of raw material from one location of the world to the other location. Let's suppose that from Tamil Nadu coast to Sri Lanka, okay, or from Calcutta to Bangladesh. So that means that Dhaka or whatever the coastal city that is there in the Bangladesh. Okay. So in this case, A comes to the ship owner and tells that he wants to transport 30 tons of fish and 10 tons of raw material. In ancient days, how it will be carried is the fish will be the fish will be the fish will be put here. Okay, let's suppose that this is 30 tons of fish. This is 30 tons of fish and 10 tons of raw material. This is 10 tons of raw material. Okay, we know that fish requires one kind of environment and raw material requires other kind of environment. Fish requires what? Cold storage. So that means some ice will be put inside the ice. Fish will be kept. Okay. But this raw material requires dry storage. Okay. So we don't need to put ice or anything in this. Okay. Now, this is the arrangement in ancient days. This is the shape. Okay. So now, during transportation, there is always a possibility for mixing up of these two materials. Okay, when the ship is going, because there is no proper containerization, there is no proper compartmentalization, so there is always a possibility that the fish and raw material will mix together. Okay, so if the fish and raw material mixing together, what will happen? The fish will die and the raw material will be spoiled. To avoid this problem, the shipping industry came up with the concept of containers. Containers are nothing but empty boxes with some volume. Let's suppose that the capacity of this container is 10 tons. 10 tons. Okay. So the total capacity of this ship is 100 tons. So 10 such boxes can be accommodated in the ship. So what was done is the shipping industry made containers which are nothing but the empty boxes. This is of 10 tons capacity, this is of 10 ton capacity, and this is of 10 capacity. Okay, like that 10 containers or 10 boxes will be made. What they have done is they have kept the fish. How fish? So they have put the ice in this box, and they have put the ice in this box and this box, and they put the fish in it. Okay, so fish requires which kind of environment? Cold environment. Okay, it requires cooling atmosphere. So that's why the fish is kept in the containers where ice was kept. Okay, this is. Now coming to raw material was put in some dry boxes. Okay, that means there is no need of ice or any special material in this. They may be applying some chemical, but that is different from the ice. Okay, so what they have done is So this is the existing setup. This is the new setup. So what they have done is, instead of keeping the material like this, so they arranged these boxes in the ship. They have arranged the boxes in the ship. Now, what happened now? Even if the ship is in transportation for hundreds of hours a days, there is no possibility of mixing of fish with the raw material because they are put inside the boxes. They are isolated from each other. They are isolated from each other. Even they were isolated from the same material itself. Okay. So the fish was isolated from fish. There is no conflict. And even if one box of the fish dies, still the fish in the other boxes is still safe. So there is no mixing up of this raw material with that of the fish or the ice which is used in this box. So how efficient this is? Here in the traditional method, there is always a possibility of mixing up these two material, thereby getting the materials spoiled. But in this case, the materials are very safe. Got it? The same thing is applied in the Docker also. In Docker, what we do is we will deploy the application in an isolated environment called as container. You can say that this is Java application and this is another Java application, and this Java application requires Java 8. This Java application requires Java 11. So we can have the two Java versions running in the same host machine. And this may be Python application, and Python is running in its own container. There is no conflict. There is no process interference between the two applications. So in the concept of containers, we have achieved isolation. So the applications are isolated where they are supposed to be isolated. At the same time, the containers are sharing the common system resources. In this case, the containers are sharing the containers of the shipping industry are sharing the same ship body. But likewise, in the container of the software containerization of in the software containers also, the applications are separated in the form of containers, but at the same time, they are using the underlying system resource. Okay, so these containers can use underlying system resources. This is the concept of containers. Okay, so to containerize these softwares, we have a platform called Docker. Okay, so Docker is a containerization tool. Containerization tool. Okay, Docker is a containerization tool. How this will be done? That is the question now. So as usual, we have the hardware we have the hardware. Let's suppose that it is having a memory of 32 GB and CPU of 8 core. Okay, so this is the system specifications. And let's suppose that we have Ubuntu operating system. Okay, in DevOps, we use Ubuntu, right? Let's suppose that this is the Ubuntu 18 or anything in Ubuntu. So on top of this, what we will install is we will install Docker, that is container runtime. Okay, so container runtime, in our case, it is Docker. So there are different containerization tools, friends, and the most popular one is Docker only. We have Podman, we have Rocket also to contain the application, but they are not fully matured. Only Docker will be installed in the current industry. Okay, so these containerization tools are called as container runtime, which should be installed in the host machine. So in the earlier setup, to install some guest operating system, what we have installed in the traditional method, we have installed hypervisor. So in this case, we will install container runtime, that is Docker. So what Docker does is it will create the containers. Okay, this is Ubuntu container. This is another Ubuntu container. This is another Ubuntu container. So we can create multiple virtual machines in the same host. If this is the case, what's the difference between the earlier setup and this setup? Okay, earlier also we have used one or the other tool. The tool name was hypervisor. Here also we are installing one or the other tool, and here we are installing Docker. And earlier also we can install the guest operating system, as many guest operating system as we want, provided that there are sufficient system resources like CPU, memory. Then what's the difference from there to here? If you observe carefully, okay, so I will take you to the documentation now. In the concept of hypervisor, if we want to install guest operating system, we have to install full-fledged operating system. That means if we want to install Ubuntu operating system, you have to install what? The Ubuntu iOS file, the IO file. Okay, so that is approximately about 3.5 GB to 4 GB will be there. So in the case of hypervisor, we have to install full-fledged operating system. So what's wrong if we install full-fledged operating system? That's your question. Okay, very important. Everything, every point I'm telling is important in this course. So here we have installed the full-fledged operating system. And in this case of Docker, we don't install full-fledged operating system. Instead, the containers will be using the underlying operating system kernel of the host. But in case of hypervisor, the guest operating system won't use the underlying system operating system kernel. Instead, we are installing the full-fledged operating system which contains the kernel as well. So here, to install this operating system itself will consume lot of system resources. Our ultimate aim is to run this application A, but to install all these things, okay, to install this guest operating system, it will consume lot of system resources and only a minimum amount of resources are available for the actual application running. Okay, so that's the problem here. But in case of containers, these containers are also nothing but virtual machines only. In case of containers, we have eliminated the need for installing full-fledged operating system. So that means here there is lot of system resources available for the application to run. But in this case, system resources are consumed very much for the operating systems itself. Okay, for this virtual machine, we have to install full-fledged operating system. For this virtual machine, we have to install full-fledged operating system. For this also, we have to install full operating system. But in case of containers, these virtual machines will utilize the underlying operating system kernel. So we can say that from this setup to this setup, we have eliminated the need for installing full-fledged operating systems in the container technology. And one more difference is, in case of hypervisor, what we need to do is to install this operating system, this guest operating system, we have to dedicate the system resources upfront. That means before installing that, while installing this, we have to specify that out of this 32 GB, we are allocating about 4 GB to this. Okay, whether you use this 4 GB for this application A or not, that can't be utilized by the other operating systems. Okay, so that is the problem. We are dedicating the resources in case of hypervisor. So for this instance also, we will dedicate some amount of resource, whether you use it or not. So that will be dedicated. But in the case of containers, we don't need to dedicate the resources upfront. Instead, the containers will be utilizing the system resources based on requirement. Okay, they will utilize the system resources. So the application A can consume as much as resources as it's want from the hardware. So here it will consume whatever it requires. But here, whether it will utilize or not, we are dedicating the system resources upfront. Okay, so this is the case from here to here. Yeah, that's it for today, friends. I will continue this discussion tomorrow. Okay, so that's it for today. If you have any questions, you can ask me. Otherwise, we can wind up this session. Thank you.
Hello, sir. Sir, one query. Like you said, the containers will be using the underlying operating system, right? Will there be
Yeah.
any performance issue? There we have dedicated OS, but here we are sharing the OS, right? Will there be any performance issue compared to virtual machines?
No, here performance will be high because if you want to spin up this virtual machine, the entire operating system has to be installed, which is very heavier. Okay, so it will take about 30 to 40 minutes to spin up this virtual machine. But to spin up this virtual machine called container, it will take very less time. Within second, you can spin up it. So here it is very high speed. There is no performance issue. Okay.
Okay.
Yeah.
Hello,
Mohammed
sir.
is asking, can we go for Kubernetes certification after this course? Yes, happily you can go for it. And please do remember that Kubernetes certification exam is a practical exam. So you have to practice the things that we discuss in the class. Yes, others?
Yes, sir.
In person, we have to go and write the certification, sir.
Yes, yes.
Okay.
Yeah, friends, please opt for it. Very affordable, 4,000 fee. Have to spend with you about 2 months duration, 45 classes. So it's very affordable and very valuable. Docker and Kubernetes very much required for DevOps. Without these tools, you can't have the DevOps. Okay. So in the chat box, we have pinned the details. Yeah, Mahmoud, there is no change in timings. The timings are very fixed. So I'm again telling you, it's from 8 p.m. to 9 p.m. IST, Monday to Saturday. Okay, 45 days duration, and fee is 4,000 INR. Recording plus live plus material will be provided through Google Drive. Yeah, somebody is asking. Yeah, Alvelu, you can find these recordings in the Google Drive. They will share with you the Google Drive. After you make the payment, they will share this with you in the Google Drive. And meanwhile, these will be publicly available. They will be sharing these demo classes through the mail. Yeah, Arjun is telling very important question. What are the prerequisites for this Docker and Kubernetes? Okay, there is no prerequisite for this Docker, but for prerequisite for Kubernetes is Docker. To learn Kubernetes, you should learn Docker, but to learn Docker, you don't need to have anything. Just you should have some basic Linux knowledge. That also we will cover here. Wherever there is the commands, we will explain. Okay, so there is no prerequisite for this. Others, any questions?
Sir, what is the current market scenario about the Docker and Kubernetes?
This is very trending, my dear. So if you know that the DevOps is very trending technology and it is evergreen technology too, because to deploy the application, we always require infrastructure. So it is the responsibility of the DevOps to create the infra. So as long as DevOps is there, as long as the software industry is there, Docker and Kubernetes is there. Okay.
Sir, actually, I am a Python developer. So is it very helpful for me?
Yes, for every developer, Docker and Kubernetes required, especially the Docker. Kubernetes keep it aside. For developers, Docker is very important nowadays because the responsibility to write the Docker file to containerize the application lies with the developers only. Okay, so this thing I forgot to tell. The Docker especially should be learned by developers and it is must for DevOps. No doubt in this.
Okay, thank you, sir.
Okay. Vijay is asking what's the last day to pay the money, sir? And this is Wednesday, Tuesday, Thursday, Friday. So 3 days will be there, and you can attend for 3 to 4 days without paying fee. After that, you can decide. You can pay on Friday or Saturday so that you will be eligible for the classes on Monday. Okay, 3 to 4 classes will be demo classes. Okay, you will be eligible. But to get the notes, you have to pay tomorrow or day after tomorrow itself, so that they will be providing with the Google Drive access. Okay. Without paying fee, you can attend 2 more or 3 more classes as well. You will get the link through the Gmail email address. Okay, friends. I hope it is clear. Let's meet tomorrow. Thank you. Thank you all. Bye.